So here, your assignment 3 is about developing the program for statistical analysis of data, in which you are considering central tendency, dispersion, correlation, and the Simpson paradox. So here, the first step that you will do is import all the required libraries for in Python programming. So we will import the pandas, which is used for data manipulation, cleaning, and analysis. It provides you the powerful data structures like data frame and series. So we will import the pandas library. We will also use the NumPy library, which is for performing the numerical operations. So it handles all the mathematical functions, arrays, the numerical computations very efficiently. So we will use this library. So we will write a statement that import NumPy as NP. Then you will also use a Seaborn library, which is used for a statistical visualization, which is built on the top of the matplotlib, which provides the provision for plotting the prettier charts in your Python program. So it comes with the attractive default themes and it works well with the pandas data frame. So that's why we'll use the Seaborn. So we will write a statement import Seaborn as SNS. So this is the first thing that we have imported all the required libraries. Then we will load the data set. So we are using the Titanic data set. So as we have used in earlier assignment, the same data set we will use. So here you have the options like there are two options. First, download the Python dataset and use it, or you can use the inbuilt library, inbuilt dataset also. So with option 1 that you have performed in the all previous assignments, like you have gone to the Kaggle, you have downloaded a CSV file, and with Titanic is equals to pd.read underscore CSV, you have provided the path of your CSV files. Okay, so this will read the file into the pandas data frame. Another option is there that you load the Seaborn's built-in Titanic dataset. So here Seaborn includes several sample datasets already, including the Titanic dataset also. So here we will write a statement Titanic is equals to sns dot load underscore dataset, and in bracket in single quote we will provide the name of the dataset. Okay, so you can check with your installations and you can use the Titanic dataset which is inbuilt in Seaborn. Okay, so in this case you don't need to download it from anywhere, so it is there in Seaborn's library. So this is a statement that you will write. I hope it is clear to you. Then in third step, it is like now actual work with the data set. So to perform the statistics, so first we need to check the basic data set information, and we are simply looking at what kind of data the data set is having. So here the Titanic data set is now stored in the variable Titanic, right? So here we have stored the data set in Titanic variable as a pandas data frame. So data frame is, you know, that it is like an Excel sheet in a memory which has certain number of rows and certain number of columns. The rows will be called as the records and columns are called as the fields. So here I first need to check the shape of the data. So that is just to have what kind of information or how the data set looks like. So here the dot shape attribute, it will return a tuple, that is number of rows and columns. So first value gives you the number of rows, that is the observations that are present or the records or the passengers information, so and so on. So the second value, it will give you the number of columns which contains the variables, the features or attributes of these rows. So this dot shape attribute, it helps us to quickly understand the data size in short. So if I write Titanic dot shape and if I try to print the contents of Titanic dot shape, so it will give you something the tuple format, like I may get 891 comma 15. So it means there are 891 passengers and 15 attributes for each passenger. So this is the simple meaning of observation. Okay, so this is the first look observation of the Titanic. Then I need to have the information, or what I can say, I need to know what are the features available. So that means what are the various columns available. So I may need to print the column names. So dot columns attribute will return all the column names as an index object. So these names will tell that what features are available for analysis. For example, the names that corresponds to the variables in a data set, such as age is there, fair is there, sex is there, and so on. So if I print Titanic dot columns, contents of Titanic dot columns, then I will get all the columns that are listed. Then in next step, I want to know the data types of each column. Okay, so this is nothing but I am performing a kind of exploratory data analysis. I mean, simply I am describing what kind of information is there, what the data set contains of. This information I am simply printing, that's it. I am simply visualizing what data is there. So in third step, I'm simply printing the types of each column. So dot dtypes attribute I'm going to use. So dot dtype attribute, this will list the data type of each column. For example, I'm having the column name with survived, which is having the entries of 0 and 1s. So which is of type integer. Okay, it has the data type of int64. Then I am having the float 64, which consists of the decimal numbers. For example, age column will be there, fair column will be there, right? Then I am having the object type. So passenger name or cabin, which consists of the string values or the text values, I can say. Then I am having the category types, where I can have the categorical variables, which is required for the efficient storage for the repeated values, for example male, female, and so on, right? So these are the two categories we have used here. Here understanding the types is very important. This is because for the statistical operations we only work on the numerical columns. Okay, and for categorical columns we might need to encode that before actual machine learning model built. Okay, so we should know what data types the data set is having. So we will try to print Titanic dot d types. So it will give you each column's data type. Then I will simply look how the dataset looks like by displaying the first 5 rows by default. So here I will use dot head method. So dot head method, it will show the first 5 rows by default. Okay, and if I want to display more number of values, so let us say I want to display 10 rows, so I will simply use dot head in bracket 10. Okay, by now for first assignment and for second assignment we have simply specified dot head, and we haven't specified any argument value to head function. Okay, so if we specify some argument, that number, so that means display the dataset information for these many rows. This is the simple meaning of this. So this is a quick way to inspect the sample data and to see how the values are stored. So this is useful for checking if the column contains the expected type of value. For example, age column. Age column should have the numeric type of a data. So if age is not having a numeric value, so that means we can quickly figure out there is a certain problem with age column and I need to process that. So I can just analyze a kind of data that is present in a particular column and I can take the necessary action. Then I need to I might need to spot any obvious data set entry errors are there or not. So to find out such things also, I need to display the information. Then I want to know is there any missing value that is represented. So missing values are generally represented with NaN, right? So that is not a number. So wherever the blank entries are there, you may find there the value written as NaN. So you can just quickly understand there is a problem with this particular field and I need to process this particular data entry, and I can take the necessary action for that. So with Titanic.head, I will simply display the first 5 rows by default, and with Titanic.head in bracket 10, I will display the first 10 rows, and so on. Then I if I need certain more information for data overview, so it is like more complete information I want to display. So with titanic.info, this function will show you the data types, the non-null counts for each column, and the memory usage. So this will give you some additional overview of the data. I can also use titanic.describe, which will give you the statistical summary of the numeric columns. So this is a new thing now. Okay. So this titanic.describe will give you the whatever the statistical information is there for each and every data column. Not every, but for the numeric columns. So for example, the shape of a data set is given, then what are the columns that are present, that is displayed, the data types values is displayed, right? So whatever we have done till now to visualize the data, the shape, the column values, then the data types, and the first 5 rows, the info and describe. The output looks like this. So shape is there, 891 entries are there, and 15 columns are there. Which are the columns that we have displayed? That column size, survived, p class, sex, age, and so on. So these are the various columns. Then data types of each column we have displayed. Okay. So this is like survived is having the integer values, p class is having integer value, sex is having the object value. That means the text is present here. Age is having float values. Then CBSP is having integer, parse is having integer, fair is having float, embarked is object. That means the text is written for embarked column. Then class is having the categorical type of data. So here, like the ordering, the numeric ordering decides there is a particular relation between the data values. Then adult underscore male, it is of Boolean type, right? Then alone, it is again of Boolean type. So likewise, each and every column's data type is displayed. Okay. Then we have tried to display the first 5 rows. By default, we have specified like only head dataset dot head that we have given, right? So it will display the first 5 rows. So likewise, so this row one, this is like 0th row, first row, second row, third row, and fourth row. So total 5 rows are displayed with indexing from 0 to 4. Likewise. Okay. Then again, we have fine. We have given the quick overview like with using titanic.info. So with titanic.info, the range index like starting entry, right? The total entries and the entry starts from 0 to 890. So this is the information about the entire data set along with the particular column, its non-null count, and its data type. Okay, so this is how we have displayed. The same thing we have done in first assignment and second assignment as well. So nothing new over here. Okay, so we have printed this. Next thing we have used titanic.describe. So this will give you the statistical summary of the numeric columns. So these are so many columns we have. Out of this, only for numerical columns, the statistical information is displayed with titanic.describe. Okay, so this is the result. So this survived, P class, age, CBSP, parse, and fair. These are all the numeric columns. For all these columns, the count is displayed. That is how many entries are there, right? So how many non-null counts are there? That is displayed over here. Then for each column, the mean value is given. Okay. So we have tried to display the mean value. Then the standard deviation is displayed. Then the minimum value that is present, that is the lowest value that is present in survived column, P class column, age column, and so on. Then the majority of the data, that is the how the data is dispersed. At 25% of the data, it is like 0 value, P class is having 2, age is having 20, CBSP is having 0, and so on. 50% of the data. For survived column it is having the 0, P class is having 3, age is having 28, CBSP is having 0, and so on. 75% of the data is having survived as 1, P class is having as 3, age is having 38, CBSP is 1, and so on. Then it also gives what is the maximum value in what is the maximum value that is present for each of the columns. So survived has 1, and obviously survived has the values as zeros and ones. So lowest value is 0 and 1 is the highest value, so max will be the same, and this is having the numeric value. Okay, so this says that majority, like most of the passengers have been survived, because 75% of the data, those are having the value as 1. So we can analyze that most of the passengers have been survived. So more than half of the passengers are survived, we can say like this. Then for P class it is having maximum value as 3, right? And its 75% is having the value as 3, so it is like more than half of what we can say, uh, like 75% of the passengers have traveled in P class as 3, right? Then most of the passengers, they have the age as greater than or equal to 38, so this is like that, right? And here the maximum value of age is 80. So this is how the analysis can be done. Okay, so this is what we have done, the statistical summary of the Titanic dataset by displaying count, mean, standard deviation, minimum value, maximum value, and the percentage of the survival, like the quartiles we have displayed, quartile 1, quartile 2, quartile 3, right? Then we can also display the measures of dispersion, that is the spread of data, under a statistical summary. So here the central tendency tells us that the center of the data, but it doesn't know or it doesn't show us how the data is spread out, how the values are distributed, like how the values are there in the columns. So the dispersion measures the variability in the data set. So by looking at the dispersion value, we can understand how variant the data set is. So here, first thing that we can display is range. So we can find out range as maximum value minus minimum value. Okay, so it will give you the total spread, but it is highly affected by the extreme values, like outliers. So if so here outliers will affect on the range, because maximum value and minimum value, it's simply the uh, difference between these two values. Okay, so that's why we say that it is affected by the extreme values, that is outliers. And how do you calculate the range is, for example, I need to find the range on age column and the fair column. So age underscore range, to calculate range of age column, I will use Titanic of age dot max minus Titanic of age dot min. So this will give you the range for age column. So similarly, range for fair column, Titanic of fair dot max minus Titanic of fair minus min. Then I am simply printing the age range and fair range. So this is about the measure of dispersion for range. Next is, okay, along with range, I can say that the 5-number summary of the data set. The 5-number summary is a quickest statistical description of the data set that we have done previously over here, this 5-number summary. So this is the 5-number summary, in which I get the information about minimum value of the data set for a particular column, that is the smallest value in a data set. Then first quartile Q1, that is the value below which 25% of the data that lies. Then median, that is Q2, that is the middle value, 50% of the data which is below, and 50% of the data which is above this value. Then third quartile Q3, this is the value below which 75% of the data that lies. Then I get the last number, that is maximum, that is the largest value that is present in a data set for a particular column. This 5-number summary is very important because it gives you a quick snapshot of the data distribution without looking at each and every value. So this shows us where the middle 50% of the data is there, uh, then where the quartiles are. It will help you to detect the outliers. So the values which are much lower than Q1 or which are much higher than Q3, these are the possible outliers. So this is a kind of analysis that we can do by looking at the Q1 value and Q3 value. Okay, because these are like the lowest value. Q1 defines you the value below which the 25% of the data lies. So we can consider those all values as the outliers. Okay, so whichever values are lower than Q1, we can find we can categorize those values as the outliers. Whichever values those are greater than Q3, that is your 75% of the data. uh, so most of the data that is below which the 75% of the data is there, that is not outlier, but all other values that does not fall in the category Q3, those will be my outliers. So, okay, any doubt in this up till now? So we know how to find out uh, that outliers calculation we have done, right? Q3 plus 1.5 into IQR. We have seen those formulas to spot out the outliers present. In second assignment we have done that, right? So this is the same thing. Okay. So if I want to understand the spread, see if the data is tightly clustered or widely spread. Okay. So by looking at the box plots, we can determine whether the data is tightly clustered within a box or whether it is widely spread across the box also. So this guides in pre-processing, which helps us to decide whether the scaling is required, whether the transformation is required, or whether I want to remove certain anomalies. Okay. Okay, so if I want to simply display the 5-number summary, we have used Titanic.describe. So this will give you the statistical summary for numeric columns of entire data set, and that is we have stored in Titanic variable. We can also display this statistical summary for a specific columns as well. So we will see how we can do this. Suppose I want to display the 5-number summary only for age column and fair column. So I will simply write print Titanic of age comma fair dot describe. So I can specify for which columns I want to have the 5-number summary. That's it. Okay. So now instead of showing these 5 numbers, that count, mean, standard deviation, minimum value, quartile 1, median, quartile 3, maximum, these values for each and every columns, now it will print it only for age and fair columns. Okay, so this is like for example, now what kind of analysis I can find out by looking at the contents of these values. So here I have count of age is 714, that means there are total 714 entries are present. So data is present for these many rows. For fair it is having 891, right? So total 891 entries do exist in fair column, right? So now if you compare, the age column has 714 and fair has 891, so you can figure out that certain data for age column is missing. So now you can analyze from this as this data set, the data set for what I can say, certain values for age column are missing, so I need to deal with those. What kind of processing techniques I want to incorporate, that I can decide. and I can take the decision accordingly. So this is how the analysis comes into picture. Then by looking at, let us say, um, hmm, let us say for age column, the minimum value is 0.42. So that means I can say that this is like a baby. So the passenger is baby, right? Okay. Then suppose I am having the maximum value for each column as 80. So that means it is like the oldest passenger. So this is what the meaning I can say by looking at the mean value and max value. Then for 25%, that is Q1, it is having the value as 20 point. So that means 25% of the passengers were younger than 20. So we can say that, okay, because Q1 deals with below this value there are the passengers, or below this value there is certain passengers likewise. See, this is now for Q1, it gives you the value below which the 25% of the data lies. Okay, so here for Q1, I got the value as 20. So I can find out the meaning as 25% of the passengers, they have the age below 20. That is the simple meaning of this. Then for 50%, that means the median value, and 75%, that is my Q3. So here I can say that this 28 is like my middle age. So if I consider the overall middle value of all the passengers, so they are having the 28. And for 75%, that is Q3, I'm having 38. So that means I can say that 75% of the passengers, they are having the age below 38. I can find out the meaning, and rest of the passengers, they are above 38. Okay, so this is what the how you should analyze the things. Okay, similarly for fare column, the interpretation that I can say that it has 891 entries, the mean value is 32. Uh, uh, then I have, let us say, minimum value is 0. So it is like some passengers, they travel for free. I can have the meaning of this. But here as it's having the 0, so there is no any count, I can say that. Right now? I hope you understood the things. See, if the fare has the value as 1, so that means there were certain passengers who paid only rupees 1, likewise. And I got here entry as 0, that means there are certain passengers who have paid nothing. This is the simple interpretation. Then 25%, that is Q1. Q1 has, it is now 7.9. So I can say that 25% of the passengers, they have paid less than 7.9 rupees. So this is the interpretation. For median, we got 14. So that means half of the passengers, they have paid less than 14. So this is the interpretation. For Q3, it is 31. So that means 75% of the passengers, they have paid less than 31. Okay. Then maximum value for fare column is 512. So this is like the most expensive fare that some passengers paid. So this is, we can say that, let us say it is the first class ticket and which is having the highest fare. So this kind of interpretation you can describe by looking at the 5-number summary as a statistical summary of a data set. Okay, got everyone? Someone please acknowledge. Yes, someone please acknowledge. I hope I'm audible to everybody. Shall I proceed again? Do you need to repeat the things or shall I move ahead? Nobody's responding.
Yes, ma'am, we got it.
Okay, fine. Next statistical measure is I want to display the central tendency measures. For example, for age and fair columns. So central tendency tells us about whether the center of where the center of our data lies. So we use three common measures: mean, median, and mode. So these give you the central tendency of any column. So calculating them for age and fair columns in a Titanic data set. So for age column, I can write Titanic of age dot mean. So this will give you the mean value, that is the average passenger age. So this is sum of all ages divided by the total number of passengers with that known age. Then median value is given as Titanic of age dot median. So this is like it will give you the middle passenger age when all ages are sorted in order. Then I can have the mode, that is the most frequently occurring passenger age in a data set. So Titanic of age dot mode dot values. So it will give you the what I can say the frequently occurring passengers age that are listed. So that is given over here. So this is like it is mostly useful for finding the most common value. The mode value is always used to find the most common value. Fine. And median value, it will be used for identifying the skewness of the data. So whether the data is skewed or not, that I can determine from median value. Fine. And mean value is generally, it is very sensitive to outliers because the outliers will affect on what mean can contain, but rest of the central tendency measures like median and mode, these are not affected by extreme values. Similarly, same thing I can find out for fair columns as well. So here I can say that by looking at uh, mean and median value, we can find out whether the data is symmetric or not. Okay. And by looking at the various conditions, like if mean is equals to median, or if mean is uh, equating towards median value, if they are like similar, there is no much drastic difference in between these two, then I can simply say that the data is completely symmetric. When I am having the mean value that is greater than median, so I can say that the data is right skewed. ठीक है. If the mean value is less than median value, then I can say that data is left skewed. So this helps us to find out where the data lies, what range the data is having. So here left skewed and right skewed is nothing but, if suppose I draw the plots in between for age column, let us say I'm having the number of passengers on x-axis and the count of age, I mean your age value on a, let us say, y-axis. So if most of the values those are lying in between 0 to 20, so that means my data is left skewed or right skewed? Tell me. Yes, it is left skewed, right? So very small values are pulling the mean value as down. And if now let us say my data is having the most of the values in between 70 to 80, then I can say that the very large values, those are pulling the mean down. So the data is right skewed. Okay. So this is the meaning that you can interpret by looking at the mean, median and mode values. Okay, so why we calculate the central tendency? To understand our data set quickly without looking at any other single value. Instead of inspecting each and every value, we can simply find out how the data is dispersed. So to see if the data is skewed, I calculate mean, median and mode, and I will check these conditions and I will determine whether the data is symmetric like the distribution of the data values, whether it is across each and every range, or it is right skewed or it is left skewed, and to decide how many missing values are there and how to handle those, right? So if the data is skewed, then whether the missing data should be replaced with mean value or median value, that I can decide. So if the data is right skewed, then I can use mean value to replace, right? If the data is left skewed, then I can use the median value to be replaced for null values. So this is what the decisions we can take. Next statistical measure is variance and standard deviation. So these are the measures of dispersion that gives you the spread in the data set. So they tell us how far the values are from the mean value. So variance will give you the average of squared differences from the mean, and why the square of differences is just because squaring of the differences is ensures all the deviations are positive, so it will give you more weight to the larger deviations, so it handles with the extreme values or the extreme outliers also. Unit of this is the squared unit of original data, so edge square or years square or fair square likewise. So this is quite harder to interpret, so we go for the standard deviation also. Standard deviation, it gives you the square root of the variance. Here it by taking the square root, it brings the measure back to the same unit as that of the original data. For example, year, dollar, fair, age likewise. And its interpretation is if I have low value for standard deviation, so that means the data points, these are close to the mean value, so that gives you there is no much spread, so it is a low spread. If the standard deviation has a high value, so that means the data points are spread for the data points are spread far away from the mean value, that means there is a high spread of the data set. So this is the interpretation we can find out from standard deviation value. So if I want to calculate the variance and standard deviation, I will simply use let us say for age column. So Titanic of age dot var. So this will give you the variance for age column. Then if I want to calculate the standard deviation for age column, then Titanic of age comma standard STD. So these are the functions that I will use. So here it is very important to note that variance and standard deviation, these both are sensitive to the outliers. So the presence of outliers will affect your standard deviation and variance. So that's why your analysis can be affected. So hence we should treat outliers immediately if they are present. Okay, here for your age and fair column, uh, you might get the age variance as 211 and standard deviation as 14.5. So here the interpretation of this value. So this means the passenger ages are, these are like moderately spread around the mean value of 30 years. I can say like this, or most of them are within the 15 years of that value. And for fair, it has got this entry and the standard deviation as 49.5. So it is like we can say that the ticket prices, these are very highly spread, and this is due to the difference between the lowest fare and the highest fare. So that's why we can say that there are certain outliers that are present and those are affecting your variance. Okay, so that's all about the interpretation of your variance and standard deviation. Then next is there is a correlation value present, that we have to display that also. So this is, we are using the Pearson correlation. So Pearson correlation for age column and fair column. You try to find out what Pearson correlation gives you. Okay, I mean, how you can interpret if you have certain Pearson correlation value for a particular column. So what is the meaning of that? So try to give me the meaning. Okay, so this is your assignment. Okay, then you are simply calculating the Simpson paradox also. Try to identify or try to learn what is the Simpson paradox, and try to interpret what the value suggests. So here for overall survival rate, I'm trying to find the Simpson paradox. So this is simply by using mean value, I can display the Simpson paradox. Okay, so I'm simply using the mean value. So this is one way to find out the Simpson paradox for a particular column. So by using the mean value, I can determine what is the Simpson paradox. So that's all for this assignment. I guess we have done with all the statistical measures for a data set. So we have identified, so we have dealt with the central tendency, the dispersion, correlation, and Simpson paradox. So this is what the assignment is about. I hope the things are clear to you.